Hey everyone, this is Master Channel here, and today we're going to be going through the circular function of tan of x. In the last video we did circular functions of sine and cos. This will be a continuation of it. So the first thing we need to know is to remember that tan of x is calculated by sine over cos. So the y value of the x, so the tangent, the gradient, in essence. And if you look at the image on the right, you can see that tan is the length. So the length TA, so if the your triangle is OX and the point touching the circle, TA is the length of the tangent. There's just a list of properties on the left of the tangent function. So the period is pi. Its range is R. Its vertical asymptotes R. This is kind of like a general solution-ish sort of thing here. K is element of Z, so Z again being part of the whole numbers. Positive integers, the asymptotes are one period apart. The x-intercepts are over a k pi. Mean position is at y equals 0, and that's just the domain. So true except with the asymptotes are, and a many to one correspondence. So if we look at good at Desmos here, so fx equals tan of x. We can see that there's like strictly these curvy lines here, and at certain points there is a sort of asymptote, vertical asymptote. You can see that this pattern keeps repeating. So you see this sort of cycle between -2 and 2. It's like, well, not -2 and 2, but somewhere around there. There's a cycle. And there's a vertical asymptote there. Sorry. The right asymptote as say pi on 2, for example. Sorry. X. You see that it's approaching, but it's never actually technically touching this line. And if we look at the graph intuitively, you can see that, okay, so if we get pi on 2, so that's sine for cos. You know that cos of pi on 2 is 0, cos the x coordinate, and here at 0, 1, the x coordinate is 0. So you can't actually divide by 0, which is why it's undefined and why it's an asymptote here. It approaches but never actually touches. And yeah, so it just comes back down and comes back up again. So right, x equals 3 pi on 2. Yeah, again, these are one period apart, and you have the same scenario again here. The x-intercepts, so right, x equals notice that exactly in the middle, smack in the middle, x equals pi. So if you go the diagram here at pi, you realize that. So that's the coordinate -1, 0. So sine is 0 and cos is -1. Sine pi is. What you need to know is that, I think importantly what you need to know is that the x-intercepts are here, just at k pi. K is a whole number. So if we go pi x equals 2 pi. The rule is still there because there's a. Actually, it's not really relevant. But the point is that's what the x-intercepts are. There's a many to one correspondence. There's also a many to one correspondence because it passes the vertical line test, but it fails the horizontal line test. Yeah. So the second part of the graph. So this is in general form: a times n, and x minus b n plus k. The period is pi on n. There's in this distance of the asymptotes. This is kind of the same thing here. Vertical asymptotes, horizontal translation, mean position, and the x-intercepts. So if we go to here, so a is your usual dilation, and when it's negative, it flips. As per usual. B is your left and right. N is how squishy, I guess, that. And K is your up and down. So no change there. And yeah, I guess that'll be all.